Hello guys, this is my first video, so very much welcome. And today we are going to solve unique parts of lattice grid. Uh, this is a question that I found during my preparation of physics entrance exam, TFR physics entrance exam to be specific. Okay, the problem says 8 into 8 grid. This is 8 into 8 grid. Okay, and this is 1 comma 1, and this is 8 comma 8, and this is 5 comma 5. 1 comma 2, 1 comma 3, 1 comma 4, and so on to 1 comma 8, and 2 comma 1, 2 comma 2, 2 comma 3, and so on 2 comma 8. I haven't written it down, but it's there. Okay, you get it right. Okay, 5 comma 5. This is a destination, and this is a starting point. The question says, how many unique paths are there to reach 5 comma 5 from 1 comma 1? Given only upward and rightward moves are allowed, ups and right moves are allowed. Okay, this is simple yet interesting. So give it a try. Okay, I highly encourage. And 1, 2, 3. I assume it did. Before we solve this question, we are going to do a little bit basics of permutation combinations. Okay, and it's going to be very much intuitive. The entire explanation is going to be very much intuitive. So in case you are an intuitive learner, you'll love this video. Please go around. Okay, please stick around. Hey, here we have two pens, and let's calculate how many ways we can arrange them. This is one arrangement, and this is second. Okay, these are the only two arrangements here. What if I bring third one in the game? What will happen? I have to repeat these two arrangements 3 more times, like 1, 2, 1, 2, and 1, 2. So 2 plus 2 plus 2, total 6. Okay. What if I bring fourth pen in the game? I have to repeat this arrangement, these 6 arrangements 4 more times. Okay. So 6 into 4, 24. What we get is, if they're like n pieces and we want to arrange them, we will have to do like n into n minus 1 into n minus 2, n minus 3, and we will present that by factorial and factorial. You'll know what factorial is just a second later. Okay. We'll use this concept to solve a problem. Okay, so let's see how the knowledge of computation or combination will help us get to the answer. I asked two questions. First, is the entire grid available to us, and how many moves we have to make to form a path? Well, the entire grid is not available to us. Why? Because let's say you go up, 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 and you take one more step in the upward direction, and then go right, 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 right. You cannot reach your destination because downward move is not allowed. Similarly, if you go right, 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 and you take one more right, and then you go up, 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 you cannot reach your destination because leftward move is not allowed. What we say is that you are restricted by this row and this column, and you have to play your game in this area only. And how many moves we have to make to form a path? Let's see. Let's take this example, this path here. It is up, 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 right, 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 right. Okay, up, 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 right, right, right. Let's take this example. This is right, 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 up, 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 up. Let's take this example. Up, right, up, right, up, right. Up, right, up, right, up, right, up, right. What we see in these three examples is that there are total 8 moves, and there are 4 ups and 4 rights in different order. Is this true in general? Yes. How so? Suppose this is a destination, and here you are, and you have reached your destination. You can take infinite paths, okay, but you have to elevate yourself in the vertical direction as much distance it requires. Whether you fly or go through tunnel, that's a different case, but we have to. And same is true for the rightward direction. And here someone will comment wormholes, but the thing is they are not engineered yet. Once they are available to us, I'll make a video on it for sure. Okay. And since our destination is 4 steps away in the vertical direction and right steps away in the rightward direction, so we have 4 ups and 4 rights exactly. and not more than that, because we are restricted by this column here. Okay, rows and column, this row and column. Okay, we have 8 moves to make to form a path. So instead of asking how many paths are there, we should ask in how many ways we can arrange 8 moves. And how do we do that? You got the answer, right? 8 factorial, 500, 320. These are paths, but these are not answer. This is not answer. Why? Because some of them are not unique. Why so? Let's take this example here. Up, 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 right, 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 right. Let's replace this u by this u. What we get? The very same thing. It does not give us anything new. It's the same path. So what we get is that interarrangement of these ups, these 4 ups, interarrangement of these 4 rights does not give us anything new. Okay, we have to get rid of them if we want our answer. If we want unique paths, how do we do that? Let's see. Okay, so in how many ways we can arrange 4 ups, 4 factorial ways, and how many ways we can arrange 4 rights, 4 factorial ways. The thing is, these 8 factorials include these 4 factorial, 4 factorial, these interarrangements. To get rid of them, we simply have to just divide. Okay, these 4 ups and these 4 rights, and if we do that, we get an answer, which is this. So hope you got your answer. And okay, the explanation was very much intuitive, and in future we'll generalize this lattice grid problem into something 2D and 3D. So for that, just follow me, subscribe. Okay, bye.